Right. So now let's try to solve a problem. How to connect solar panels in which connection? Parallel connection of same rating, and how to connect solar panels of parallel connection which rating? Different rating. So whether connecting in same rating is good or connecting in different rating is good, which will influence us. Let's try to calculate. Okay. So you see here I am taking a solar panel or a solar module. So this is module 1, this is module 2, and this is module 3, which is giving an maximum voltage of 17 volts and a current of 5.1. Or therefore what is the maximum voltage? Vm into Im. What is the maximum power you are going to get? 17 volts into 5.1 ampere. Multiply it, how much it is? Louder. 86.7 watts. So similarly I have the second panel with Vm and Im. The maximum power is Vm into Im. What is that value? 83.3 watts. Next one, 17 into 5, 85 watts. So now add all the three powers, 86.7, 83.3 and 85 watts. So total power, how much? 255 watts, and this generally we will call it as the peak value. This is directly we are calculating power and we are adding P1, P2, P3. But all these panels are connected in series or parallel? Parallel. When they are connected in parallel, what is common? Voltage is common. So what is this Vm value? Vm is how much? 17 volts. But the VMA of the array is also how much? 17. Why? Because they are connected in parallel. What is IMA? The maximum voltage of the array is equal to how many number of panels are connected in parallel? 3 numbers. Okay. Or you can see here this is nothing but when you connect the solar panels in parallel, current will add or subtract? Add. Okay. So what is the magnitude of current? Magnitude is 5.1 plus 4.9 plus 5. So this how much? 15 amperes. Now IMA is 15 amperes, VMA is how much? 17 volts. So how to calculate the maximum voltage of the array? Maximum voltage of the array is equal to VMA multiplied with IMA. So what is VMA? 17 volts and current is how much? 15 amperes. Scale it and say the product to 55. So if you add by this procedure or if you add by this procedure, answer is same. So here what I have to understand is these three panels are connected in which connection? Parallel connection. Therefore what is additive? Voltage is same. What is additive? Current is additive. You got the power. So this is how. I think you no need to show the diagram. So already we done for 2 panels. So this is for how many panels? 3 panels. So take 3 panels and join the positives. So this is all positives, this is all negatives. Okay. So now you are going to join all these terminals are positive terminals. You join all the positives, you will get positive polarity. You join all the negatives, you are going to get the negative terminal. So this is what the original combination. Okay. So here you have panel 1 rating, panel 2 rating and panel 3 rating. So similarly when you connect the solar panel of same rating like 7 volt, 17 volts, 17 volts, 17 volts, same operating voltage, there is no problem. Why? Because they are connected in parallel. But if you select a solar panel, for example you understood that this panel is of 100 watt peak and this panel is also 100 watt peak, this panel is also 100 watt peak. Now with same rated you connected them. Now let's try to check out if you connect in different rating what will happen. Okay. So I'm selecting the first one is 100 watt peak, next one is 80 watt peak, next one is 70 watt peak. 3 different ratings I selected. The corresponding module is giving Vm voltage and Im is how much? 2 amperes. Voltage is 18 volts and current is 2 amperes. Voltage is 15 volts and current is 2 amperes. So if you want to see this diagram you can see here. So what is the voltage of each panel? So let us take this panel. What is the voltage? 20 volts and current is how much? 2 2 amperes. Okay, and see the next panel. So this is 18 volts and how much current? 2 amperes. This is also injecting how many amperes of current? 2 amperes. Okay, next one, 15 volts and how many amperes of current? 2 ampere. This is also injecting how many amperes of current? 2 amperes. So this is injecting 2 and this is also injecting 2. Resultant Ix is 2 plus 2. 2 plus 2 is how much? 4 amps. So resultant current of the array is how much? 2 plus 4. 2 plus 4 is how much? 6 amperes. But coming to the voltage, how much voltage this panel is generating? 20 volts. Here how much you are going to get? 20 volts, and here how much you are going to get? 0 volts. And here this is how much voltage? 18 volts, and this is how much? 0 volts. And this panel is generating how much voltage? 15 volts. Up to now you studied your circuits. In parallel, what is constant? Voltage is constant, but these panels are of one is of 100 watt peak, and next one is of 80 watt peak, and next one is of 70 watt peak. Each panel is of different rated. Since it is different rated, the voltage levels are also different. So now 20 is there, 18 is there, and 15 is there. Which will be the parallel voltage now? Whichever is the lowest voltage, that only will be considered. Okay, so here what is the lowest voltage? 20, 18, 15. What is the lowest? 15. So in this three combination, which is the lower one? 15 volts. Therefore the maximum voltage of the array will be whatever may be the lower voltage. And I already told these are connected in parallel. When they are connected in the parallel, as per the circuit diagram, the maximum current of the array 2 plus 2, 4, 4 plus 2, how much? 6 amps. Now what is the maximum power of the array? The maximum power of the array is equal to how much? VMA scaled with IMA. So what is VMA? 15 volts multiplied with 6 amps. What is this value? Louder. 91 watts. Huh? Okay, approximately 90 watts. So now how much we have been lost here? So here 5 volts have been lost here. Here how many volts have been lost? 3 volts have been lost. Okay, so now is it recommendable to connect the panel like this of same rated or different rated? You should all the time connect only same rated to 100% utilize the efficiency of the panel. If you connect 3 different rated panel, which is a meaningless design, it's not like meaningless design, you are not supposed to connect. If you connect, what will happen? You are unable to make use of 100 watt, only what we are going to make use of. So the complete system is acting like an how many watt panel now? 70 watt. So 70 plus 70 plus 70, how much? 210 watt. Generally you add these 3 wattages, how much? 100 plus 80 is how much? 180. 180 plus 70, 250 watt peak. But actually now what's happening? So but only 70 is considered. So 70 plus 70 plus 70, how much? 2. How much is the loss? 40 watt have been lost due to connecting them a different rated. So 40 watt panel capacity we are unable to utilize. Why? Because here 10 is lost, here how much is lost? 30 is lost. So 10 plus 30 is how much? 30 watts of power we have been lost. Okay, so that is why we are not going to recommend to connect solar panels of which rating? Different rating. It is suggestible to connect the solar panels of which rated? Same rated. That's what the conclusion from the problem. Okay, so directly I had done, since they are connected in parallel, if you want to do it, you can do like this also. So individually you can calculate 2 into 2 and 18 into 2 and 15 into 2. Here you will get some value, and here how much you got? 90. No, here you will be getting plus 40. So plus 40 means how much you are going to get? 90 plus 40, 130. So the loss is how much? 40 watts. Why? Because directly you are adding here. But in system, what will happen? It will consider only which voltage? Whichever is the lesser voltage. Okay. So this is how to connect the solar panels of same rating and different rating. And what is the conclusion of this experiment? You are not supposed to connect the solar panels of different rating in series as well as in parallel. If you connect, we want to take only reduced efficiency. There is a lot of loss. Load. ಗೊತ್ತಿಲ್ಲ ನಾನು అదే మన రికార్డ్ చేసుకోవాలి. Doesn't seem good. So a problem is given to us. Estimate the number of modules to be connected. Is not saying series or parallel, to give an maximum power. Okay, we need to calculate how many number of modules are to be connected in either series connection or parallel connection to generate a maximum power with an maximum current of the array is how much? 96 amperes, and maximum voltage of the array is how much? 35 volts. Okay, and you can see this panel, the panel or the module is having a open circuit voltage under no load condition is how much? 40 watts. The short circuit current is how much? 8.5 amperes, and it is delivering the maximum voltage at MPP is 36 volts, and maximum current at MPP is 7.5 amps. You are very clear about these parameters, yes or no? Already we discussed in the class. So now we need to find how the modules are connected. So how to calculate the number of module? You see here, this array and maximum voltage of the array both are same. So I can say that these are not connected in which connection? Series connection. But when you see the current and when you see the resultant current, you can see the current is scaled up. I can say that these panels are to be connected in which connection? Parallel connection. So now how to calculate that? Okay, so what is the formula we have is the maximum current of the array is equal to number of panels to be connected in which connection? Parallel connection multiplied with individual current rating of the panel. What is individual current rating of the panel? IM. So what is the array current given? 96 amperes divided by what is the IM value given? 7.5 amperes. That is equal to number of panels to be connected in parallel. To this value 12.8. So generally you will not have 12.8 panel, 12.5 panel. So we are going to round it off and we are going to call this as how many panels you require? 13 number of panels are to be connected in which connection? Parallel connection. How many panels you have to connect in parallel now? 13 panels of this rated. So now you got the clarity. Now how to calculate the maximum power of the array? The maximum power of the array is equal to the maximum voltage of the array multiplied with the maximum current of the array. Okay, so what is the maximum voltage of the array given in the problem? 35 volts. And how to write down the maximum current of the array? You had already got 13 number of panels multiplied with what is individual current? 7.5. To do this calculation, 35 into 13 into 7.5, 3412.5 watts. Actually we want to express our solar panel generally in kilowatts. So how to express in kilowatts? So since I want kilo, I am multiplying with 1000, and the same effect I am going to nullify by dividing with 1000. So when I divide with 1000, how many decibels it will come out? 3 decibels, 3.412, and this 1000 I can write down it as how much? Kilowatt. Okay, kilowatt, and suffix you are going to write down it as peak. Now what is the rating of the solar panel? I mean, what is the rating of the plant? P maximum. What is the rating of the solar plant? 3.4 kilowatt peak is the rating of the solar panel, and this is the individual rating. So how to connect them in parallel? You take panel 1 like this. Okay, take parallel 1 like this, and how many panels you have to select like that? Panel 2, and similarly how many panels you are going to get? 13 panels with the terminals of what? Positive and negative. So the terminals of positive and negative. So join all the positives, join all the negatives. Yes or no? So each panel is generating a current of how much? 7.5. So the resultant current in this branch is 7.5. The current in this branch is how much? 7.5. This will be added. So 7.5 plus 7.5, how much? 15. 15 plus 7.5, like that. The total current what you are going to get in the maximum current of the array is how much? How much you are going to get? 96 amperes, and I can say that they are connected in parallel. When they are connected in parallel, what is the voltage you are going to get? What is the voltage you are going to get? 35 volts, or is as per the given specification, just 1 volt is lesser, 36 volts. You multiply 36 into 96, you will get the same 3.4 kilowatt. So this is the circuit diagram of how these panels are connected as per the given problem. Now what is the rating of our plant? 3.4 kilowatt. Each panel is having Vm and Im value. So it is generating a current of Im and a voltage of how much? Here what is the voltage? 36 volts. Here how much is what? 0 volts. 36 volts, 0 volts. Similarly, one more panel, 36 volts, 0 volts. Similarly, up to there, how many panels? 13 panels are connected in parallel to generate a maximum voltage of the array as 36 volts and a current of how much? 96. When you do the product, then you are going to get 3.4 kilowatt. This is how many number of modules are there as per the problem? 13 modules. What is the rating of the plant now? 3.4 kilowatt.